What if black holes, those mysterious cosmic giants, were not just destructive forces, but gateways to entirely new universes? Imagine traveling beyond the edges of our known cosmos, stepping through a portal to worlds we've never dreamed of. Black holes form when massive stars collapse, creating regions in space where gravity is so strong that nothing, not even light, can escape. Traditionally, they're seen as cosmic vacuum cleaners, swallowing everything in sight. But modern science suggests something far more intriguing. At the core of every black hole lies the singularity, a point of infinite density. Surrounding it is the event horizon, the point of no return. What happens beyond this boundary remains one of science's greatest mysteries, but some physicists propose a mind-blowing possibility. Black holes might connect to other universes through what's called a wormhole, a theoretical tunnel linking different points in space-time. If a black hole is really a gateway, that means traveling through it might lead you to a whole new universe with different laws of physics. The end of our universe could be just a doorway to another cosmic reality. Maybe our own universe was born from a black hole in a different cosmic realm. Researchers use quantum mechanics and Einstein's general relativity to study these links. Although wormholes face challenges like stability, new theories involving dark energy and exotic matter offer hope that such gateways could exist. This idea pushes us to rethink our place in the cosmos. It sparks imagination and fuels endless questions. Could life exist in these other universes? Could black holes be our passage to future exploration? If this mysterious cosmic portal fascinates you, hit like, subscribe, and ring the bell for your front row seat to the universe's most mind-bending questions. Share your own theories in the comments. Which universe would you want to visit if you could? Stephen Hawking's groundbreaking work revealed that black holes aren't completely black. They emit radiation and slowly evaporate over time. This discovery led to the famous information paradox. If black holes evaporate, what happens to the information that fell into them? Some scientists propose the holographic principle, that all the information about what falls into a black hole is encoded on its surface like a cosmic hard drive. Others suggest the firewall hypothesis, that crossing the event horizon would incinerate anything attempting to pass through. String theory adds another layer of complexity, suggesting that black holes might be gateways not just to other universes, but to other dimensions entirely. The Event Horizon Telescope gave us our first direct image of a black hole in 2019, confirming Einstein's predictions about their structure. LIGO's detection of gravitational waves from colliding black holes opened a new window into these cosmic phenomena. When black holes merge, they create ripples in the fabric of space-time itself, confirming our understanding of gravity on cosmic scales. The concept of eternal inflation suggests that our universe is just one bubble in an infinite cosmic foam of universes. In some of these parallel universes, the laws of physics might be completely different. Gravity could be stronger, atoms might not form, or time itself could flow backwards. Quantum mechanics shows us that particles can tunnel through seemingly impossible barriers. Could consciousness or information do the same through black holes? Some theorists speculate that if black holes are gateways, they might preserve not just matter and energy, but the patterns that make up consciousness itself. Near a black hole, time slows down dramatically. What feels like minutes to you could be years to outside observers. Advanced civilizations might harness black holes as energy sources, using their rotation to power entire galactic empires. Scientists are even exploring the possibility of creating artificial black holes and particle accelerators, though these would be incredibly tiny and short-lived. Black holes could serve as cosmic highways, allowing spacecraft to travel vast distances using gravitational slingshot effects. Imagine falling into a black hole. From your perspective, you'd experience spaghettification as tidal forces stretch your body. But to outside observers, you'd appear frozen at the event horizon, your image slowly fading and reddening over millions of years. If you somehow survived the journey through a black hole gateway, you might emerge in a universe where the fundamental forces work completely differently. Perhaps you'd find yourself in a universe where time flows backwards, where broken things spontaneously repair themselves and effects precede their causes. Or you might enter a realm of higher dimensions where three-dimensional thinking becomes as limited as a flatland creature trying to understand depth. The energy required to keep a wormhole stable would be astronomical, possibly requiring the mass energy of entire stars. Exotic matter with negative energy density would be needed, but we've never observed such matter in nature. Even if we could create a wormhole, it would likely collapse faster than light could travel through it. Traversable wormholes could potentially allow time travel, creating paradoxes that might violate the fundamental structure of causality. Quantum fluctuations in the vacuum of space might destabilize any wormhole before it could be used for travel. If black holes truly connect infinite universes, what does that mean for concepts like uniqueness, purpose, and individual significance? Could there be infinite versions of yourself living different lives in universes accessible through black hole gateways? Some philosophers wonder if consciousness itself might be a fundamental feature of the universe, preserved and transferred through these cosmic portals. In universes with different physical constants, would mathematics still work the same way? Would logic itself remain consistent? Could advanced civilizations use black holes as communication networks, sending messages across the multiverse? Today's physicists are using particle accelerators to probe the fundamental nature of spacetime at the smallest scales. They're working to unify quantum mechanics with general relativity, hoping to understand what really happens at a black hole's singularity. Powerful computer simulations are modeling black hole interiors and testing whether stable wormholes could exist under any conditions. New space-based telescopes are providing unprecedented views of black holes, testing Einstein's theories in the strongest gravitational fields in the universe. Research into quantum entanglement might hold clues about how information could be preserved or transmitted through black holes. Whether black holes are gateways to other universes or simply the universe's most extreme gravitational phenomena, they remind us of how much we still don't know. They challenge us to push the boundaries of human knowledge and imagination, to ask questions that seemed impossible just generations ago. Every child who looks up at the night sky and wonders what if, is participating in the same spirit of inquiry that drives our greatest scientific discoveries. The universe is far stranger and more wonderful than we can imagine. And black holes might just be our first glimpse into realms beyond our wildest dreams.